Good evening everyone. Kumusta po ang araw niyo? Kumusta po kayong lahat? So for tonight, we are going to discuss what is a transformer. So before we continue on our AC circuits, I would like to insert this discussion. What is a transformer? So a transformer is an electrical device that transfer electrical energy from one circuit to another through electromagnetic induction. Okay? So we have the primary components of the transformer, and we have a primary coil, secondary coil, magnetic core, insulation. So there are many types of insulation used in uh, in a transformer during manufacturing. So the application of the transformer are power distribution, electronics devices, industrial control, communications. So power transformer, we have seen a lot of this in our mostly in our power substation, electronic devices. Yes, it is also used industrial controls. So we lots of manufacturing use of this or the application and communication as well. Okay, so I have here the schematic diagram of a transformer, a basic schematic diagram of the transformers. We have uh, the input, this one, the input, and we have the output here. Okay, so we have a primary voltage V1, secondary voltage V2, and we have a turns ratio in our in a transformer. We have a primary coil, this one primary coil, and the secondary coil. So we have a formula for the turns ratio. So turns ratio is N1 is to N2 is equals to V1 over V2. Okay? So if we will, or N1 over N2 is equals to primary voltage over secondary voltage. So if we are going to compute the output voltage of the transformer, like this one, so the formula for V2, so we have V2 is equals to N2 N2 over N1 times the primary voltage. Okay, so that's it. You can interchange, or you can manipulate the formula if you're looking for the turns ratio. Okay, so I have here exercise. This one. What are the peak uh, load voltage and DC load voltage if the turns ratio is 5 is to 1? Supply voltage is 120 volts and the frequency of 60 hertz. I draw the schematic for this problem. So we have a input voltage of 120 volts, and then the turns ratio is 5 is to 1. So assuming this is a half wave transformer, excuse me. So the formula, so before we compute the the peak voltage, we need to find what is the secondary voltage. So the formula for the secondary voltage, so we have, so from this one, so uh, V2 is equals to N2 over N1 times V1. So our turns ratio here is 5 is to 1. So one turn at secondary and 5 turns at the primary. So times 120. So we have 24 volts for the secondary voltage. This one. Okay. And the peak voltage. secondary, so we need also to find the peak voltage at the secondary. So peak voltage at the secondary is V2 V2 over BP is equals to 0.707. What is 0.707? This is the ratio of the VRMS over the peak voltage. So since we are looking for the BP or peak voltage, so we have already value for B2, 24 volts over 0.707. So we have 34 volts at the secondary voltage. And then so we have already a value for a peak voltage at secondary. Then we can now solve the DC load voltage. So uh, the formula is BDC is equals to B peak over pi. So since we are only dealing on the half of the signal, so that's why we have pi, the half revolution of the signal. So BP is equals to 34 volts over 3.1416. So the load voltage, the DC load voltage is 10.8 volts. Okay, this one. So we have also another method. If if you watch my previous video about the diode theory, we have three approximation methods on solving the the output voltage. Okay, so I think we can also use the second approximation method in solving the output voltage of this problem. Okay, so we have formula BP is equals to 34 volts minus zero point 0.7. Zero point 0.7 is the voltage drop, assuming this is a half wave rectifier transformer. So we have 0.7 for the voltage drop. Okay, so we have 33.3 volts, and then calculating the DC voltage, VDC is equals to B peak over pi. So we have 33.3 volts over 3.1416. So we have 10.6 volts for the uh, using a second approximation method in solving the V out. Okay, thank you.